Hello, everyone. So we've got our problem of the week. It says 3 to the power of 6 is equal to 729. The units digit of 3 to the power of 6 is 9. 3 to the power of 11 is 177,147. And the units digit of 3 to the power of 11 is 7. And when you have 3 to the power of 20, the units digit of that is 1. Now, Indy wanted to find out the units digit in 3 to the power of 23 and 3 to the power of 68. She tried using her calculator, but both answers only gave her an approximation in this form. So 3 to the power of 23 is 9.414 something times 10 to the power of 10, and 3 to the power of 68 is approximately 2.781 something times by 10 to the power of 32. And therefore, this does not help her determine the units digit. Now we want to investigate and help her out. So it's a problem of the week. It's not about giving the answer or the first one handing in the answer, but it's about us showing our thinking about the problem. And for each of these problems of the week, there is a focus strategy. So we've got a bit of a hint as to how we will be able to attack the question. And this week's focus strategy is look for a pattern, okay? So when we want to look for a pattern, it gives us a clue already that maybe if we start with what we know or something that we can actually write down or list down, then maybe there's a pattern that we can use so that we will be able to figure out what would be the units digits for 3 to the power of 23 and 3 to the power of 68. So let's go ahead and write down what we know, list down all those 3 with a power. So let's start with 3 to the power of 1. We know that 3 to the power of 1 is equal to 3. And maybe we can have a column here to say what's the units digit when we have 3 to the power of 1, right? 3 to the power of 2 would be 9. 3 to the power of 3 is 27. So the units digit here is 3, 9, and then this one 7. 3 to the power of 4 is 81, and therefore the units digit is 1. If we go 3 to the power of 5, you're most welcome to use your calculator here. 81 times 3 is 243. The units digit here is 1. The units digit here is 3. 3 to the power of 6. Let's maybe put some more up to 3 to the power of 8. And what's 3 to the power of 6? That's 729. And the units digit is 9. 3 to the power of 7 is 2,187. The units digit there is 7. And 2,187, says my calculator, is 6,561. And therefore the units digit is 1. So now we can have a look at that. We've got a pattern here. It looks like it's 3971, 3971. And I would be guessing if I continue that, I would have that same pattern there. So that therefore is your pattern. Now you want to write down or maybe devise a way so that you'd be able to write down what you're thinking, right? So you could write down, there is a pattern, the units digit goes 3971, but how would you know which one would be, would have a units digit of 3, which one has a units digit of 9, 7, and 1? Well, what we do know is that we can call this what? The 4 and the 8, those are multiples of 4. So then maybe what you could write down is what? When the index is a multiple of 4, what happens? The units digit is 1, right? So you could also maybe say, let me change the color of my pencil. What would be so if you say multiples of 4, you could probably say multiples of 4 if the index is 4, 8, 12, 16, 20, etc., then the units digit would be 1, right? And if you have 5, 9, 13, right, etc., or you could probably say it's a multiple of 4, but add 1, then your units digit would be what? 3, right? And then we've got what? 6, 10, 14, etc. Or you could probably say multiples of 4 plus 2, right? You could say that the units digit here becomes 9, right? And then if it's 7, 11, 15, etc., or your multiples of 4, but you add 3, then your units digit becomes 7. Now that you've got those rules there, what you could probably say is, or you could probably use that now, since we know that 3 to the power of, what are we looking for? 3 to the power of 23 and 3 to the power of 68. Well, since you've got 23, now you want to evaluate whether 23 is a multiple of 4. We know if it's a multiple of 4, if we can halve it twice, but we can't halve it twice. We have a leftover of what? Of 3, and therefore you could say that this one is equal to 20 plus 3, which means that it is a multiple of 4 plus 3. And what does that tell you? It tells you that the units digit, therefore, units digit is 7. Okay, and then if we have 3 to the power of 68, you look at the index. 68, let's try if we can halve it twice. Let's half 68, that's 34, half it again, you have what? 17, and therefore 68 is a multiple of 4, and therefore the units digit is what? 1. Okay, so that's how we solved it, by looking for a pattern. Of course, before you would be able to look for a pattern, you would need to firstly list down some things that you know, and from that you look for a pattern and use your pattern for you to answer the question. And maybe a next step or a next question that you could investigate here would be other numbers. If it's 4 to the power of something or 7 to the power of something, do they have patterns as well? Okay, now you could do that as a practice, or you could also do this next question. Well, this is not the week 2 problem, but this is a problem wherein you would be able to use the same strategy, looking for a pattern. Indy receives an allowance of $100 a week from her parents. Her parents offered her an alternative and suggested that she get $1 on the first week, $2 on the second, $4 on the third, and $8 on the next, etc. Do you think Indy should take them up on it? Now, you want to show all your working. You want to maybe list down things, and what pattern would you be able to figure out so that you'd know whether or not Indy should remain with a $100 a week allowance, or that she takes that offer from her parents. Okay, so good luck. And if you've got any questions, please feel free to email me. All right, stay awesome and see you next lesson. Bye.
Come on, Rocky, let's go.